very warm welcome to everyone. Do what needs to be done. Some might say that forms the essence of a meaningful academic makerspace. Could this help build the entrepreneurs of the future and foster a bit more creativity? To break it all down, please help me welcome Vincent Wilczynski, Deputy Dean of the Yale School of Engineering and Applied Science.
Teresa, very nice to meet you. Thank you for that warm welcome. And I look forward to our dialogue and to share some of the lessons learned in the area of academic makerspaces with the people listening and participating in your forum. So thank you very much. And I'm honored to be part of this international collaboration.
Professor Vincent Wilczynski, my first question to you, and just to sort of get the ball rolling in the right direction, if you could just let us know a little bit about the concept of makerspaces. What really are these according to you?
Sure. The makerspaces, as you said, I really like the phrase, the doer of what needs to get done, because they serve as that platform, whether within a community, whether within an academic institution such as higher education. So as a platform, they are a location. You can think of them as a magnet that draws in talented people, that draws in interested people that want to solve engineering-based problems. And as that source, they provide the resources. Sometimes those resources are physical, sometimes that they are software, sometimes that they are person-based resources to guide their thought pattern from an initial idea into creating something. And as they do that, what is really key, and hopefully we'll be able to speak more about this in depth, is the fact that what forms within this institution of higher education is a special community, a special group of individuals that includes faculty, that includes staff, that includes administrators, but most importantly includes the doers of what needs to be done, the students themselves. And so as this collective community, there's this appreciation that the community itself can help each other learn, help each other design, help each other grow, and create a forum where people can come together, share their experiences, and transform ideas into reality, transform a concept into a physical prototype, transport a thought into a working piece of software. And so that's what's really exciting about these maker spaces, locations, but the locations are just the single point, that magnet that I spoke about. And the more important aspect is what they do is serve as a magnet for the entire community. And that's why it's really exciting within higher education to have this concept of makerspaces become so apparent, so useful, so exacting, if you will, that they provide that forum of transferring that engineering equation, that fundamental engineering skills, into actually something practical, which is what our graduating engineers will ultimately do.
Thanks for that, Professor. I sort of really love the expression that it is the power of the community that brings students together to convert ideas into reality. And that is exactly what engineers should aspire for. So if you want to give me some context on what would you say have really been the watershed moment when it comes to the evolution of academic makerspace in the US, what do you think were those tectonic shifts that actually helped to make these academic makerspaces successful?
So it's a very interesting question that you ask. One is, what's the watershed moment, and what is then the shifts that have made these possible? And you're going to hear, I think, as you think about the shifts, the causes itself. So there'll be a little bit of floating between the two questions that I'd asked. But the fundamental shift that allowed academic makerspaces to come into being is in fact the creation of this general concept of makerspaces within the community. So to go back and to see, well, where did that actually come from? It actually presents a chance for a little bit of a technology journey into how these topics, how these concepts, how these tools transferred from being industrial based to personal, to individual based. And it really starts with the transistor, the production of microchips in the 1970s. So when that happened, that very precious tool that was only available to industries and to highest levels of government and really only at the research phases of the university, once those chips began to be mass produced, they then were available to the larger community. And so what you had was this first shift of industry to the person and embodied in the personal computer. So before the proliferation of microchips, computers were rare. After it, they became personal. So you had that first example of a transfer of an industry tool to an individual tool. Once that tool was available, the computing power, the software was the next tool to transfer over from the industry to the person. And the first one was, amongst the first, was the design of PCBs. So the Eagle software, which allows you to do traces and put in resistors and transistors, came about in 1988. And so now an individual, independent of a company or a research institute, could design their own microprocessor boards. That was quickly followed by an analogous development within computer-aided design. And so having computer-aided design available on your desktop, the company SolidWorks made that available in 1997. So we have these first two bits of software. Once that happened, the floodgates really opened up, where that technology of the microchip could be put into industrial uses and then accessed by the individual. So companies such as ShopBot, which produced the first computer-controlled router for, in essence, small-scale use, not industrial use, but small shop use, academic use. A mill soon followed from Tormach in about 2008, the laser cutter in that period as well. And then the tool that really became most prominent was in 2009, the MakerBot, the 3D printer, which made creating available to all. So you have this electronics, you have this software, you have these tools, but then two other things happened. And that is in 2000, with the internet, the use of blogs and community spaces for people to come together and share ideas. And then in 2005, the development of YouTube. So no longer do we need to transcribe things or show pictures. We could make small videos to show how do you program one of these tools? What are some of the output of these tools themselves? So that's all the backdrop. And these tools first got put together in community spaces, libraries, maybe small workshops that were owned by an individual that welcomed in members. So you had this concept of public makerspaces. In 2005, a magazine was created called Make Magazine. And it advocated this concept of do it yourself, DIY concept in 2005. By 2010, that shifted over to do it with others. And that do it with others really reflected that sense of community sort of coming together. And that once it was established within communities, that it migrated its way into higher education for all the reasons that I said. The students are there, the faculty are there, these tools are there, they're accessible, available, affordable, and students are coming in with that expectation that they have access to this same type of technology that literally they have grown up with. So along the way, there's been a number of shifts. One was within engineering education itself, the shift away from formulas to actually design. That was promoted out of MIT by Professor Woody Flowers, hands-on, open-ended problem solving. The accreditation boards themselves favored design as a component of engineering education all around this same time in the 2000 or so. As I've said, these tools are now available, they're affordable, they're accessible. There's worldwide communities, thanks to the internet, of actually using them. And we see this shift within engineering, not just to formulas, but to competencies, not just to calculating, but creating. And so you put all of those things together and you've got this entrance of this ability to create within engineering education. So when the academic makerspaces first arrived on campus, many of them were housed in schools of engineering and within engineering programs, but based on the community that they came from, the public community, the open community, they're open to the entirety of community on campus. So you had artists coming together, you had journalists coming into the makerspaces, you had the engineers, and it really became this central site for this exploration of technology, this application of technology to problem solving. So in summary, what had happened is that the technology became available. It was used by communities, and those communities influenced higher education to make it part of the learning experience for our engineering students.
Thanks for that, Professor, and so beautifully explaining in terms of tectonic shifts and the watershed movements. You began your conversation from the example of microchips to the Maker magazine to how far we have come in the power of community, an essential part of what is now the experiential learning. So based on your conversation, Professor, I want to understand from you that what do you think are some of the powerful insights that could be leveraged by, say, Indian campuses, especially when there's a mindset and true intention to imbibe more experiential learning? And at the same time, what would you caution against a blatantly copying pasting the model? Because that's a very famous maxim in India that we follow a cut and copy paste model. So of course there are two things. One, what would you advise on what we could leverage from the examples in the US? And second, what we should avoid, we would caution against blatantly copying.
I think the question that you're asking is actually the very same question that was asked around the world, and especially in the United States, in the era that I had just covered around 2000, where the shift went from rote learning to actually applications. Hand in hand with the academic makerspace movement was the creation of colleagues. There's a group of us, about 7 universities, Yale, MIT, Georgia Tech, Stanford University, University of California, Berkeley, and others, that have come together to discover, vet, disseminate best practices in academic makerspaces. And so we do that with an international symposium. And so all of our work as a group of 8 universities, sort of assisting and guiding the world itself, is available. And so anyone listening to the podcast could just look up International Symposium on Academic Makerspaces, and the proceedings, the posters, the PDFs of the presentations from 2017 to 2024 are available. And what do these do? They do exactly what you're asking. They are the research, they're the applications of principles within academic makerspaces that are best practices. So I urge the listeners to make use of this worldwide community. And in fact, our next meeting is in University of California, Berkeley in August of 2025. So anyone that's really, really interested can look at the published material and then come and meet with colleagues and be a part of this community, because that's what's at the heart of the academic makerspaces. Some of the characteristics of makerspaces, I think, are really, really key as a nation or an institution would be putting them into place. And it really starts with what you've alluded to, is that makerspaces are learning spaces where learning is primary and everything actually supports the learning. It's easy to get distracted that makerspaces are creative spaces, makerspaces are entrepreneurial spaces, Maker spaces are skill spaces. Those are all components, but it really is the learning that is fundamental to the makerspace itself. The concept of community is really, really key within the makerspace. So a successful makerspace really has to be designed so that allows that community to interact. It has to be designed so that there are tools in areas for making. It has to be designed that there actually are spaces to go ahead and assemble those fabricated engineered systems together. So those three components within a makerspace are really important in its design, that it needs areas for the community to interact, areas to build, machine, program, and then areas for the projects themselves to go ahead and develop. As I said in the first question, the community has various components. It is a community for students, but not exclusively. The good thing about the library is that it's available to the entirety of the university, entirety of the public, a city. And so similarly for the makerspaces, that the faculty can come in there not just to teach, but also to learn and to build. The administrators can come in to be a part of the community, and the staff itself is part of that community. Some of the key elements that are important for the community to work is that it's built on this sense of trust. The makerspaces aren't a space with a series of rules, but rather they're this team, this culture that is helping each other learn. And so there's this openness that mistakes will be made, mistakes are accepted, they're part of the learning process, but the community is there to learn from those mistakes, to guide that development, to have that trust in the students, to have that trust in the members of the makerspace community itself. Part of that trust is key to the concept of access. It is not unusual for spaces to be open 24/7 so that they have a schedule that adjusts a little bit more perhaps to student learning, student life, than the typical start in the morning and close in the early evening. Now, the safety is an important part of the culture itself, but that can be accommodated by having only certain tools, only certain areas available when staff or assistant isn't there. So taking this concept of community, understanding the trust, carrying it over into an area of access is really, really important. The last point on the attributes is that these spaces can't exist just because you have a physical location, you have tooling, you have training, but yet they need to be supported by programs. They need a staff, they need leadership that supports learning within the space, making within the space, and sharing within the space, from an informal to the most formal parts of the academic system. Take learning, for example. Informally, that staff can lead workshops. What's an introduction to programming? How do you work with CAD? There can be specific training, a little bit more formal, on using the tools. And then finally, academic courses can actually be taught for credit. So you have this range of offerings from informal to formal so that it creates a robust set of programming. Now, on some of the cautions that for a group that would be starting out is learn from your peers. Just like the makerspace community learns from each other, those that are creating makerspaces, you are now part of this global community. So reach out to other makerspaces, do your own homework to find out what type of resources are available, what type of spaces are available, what type of community that you want to build. And you have the chance of using that experience within your own setting. That maybe you want to favor entrepreneurship over electronics. So that is your choice within your community. hopefully you'll find on your outreach that this community, as I alluded to in one example, the Higher Education Makerspace Initiative that puts on the International Symposium that makes all of its information available online, is a very welcoming community, and it sort of sets the stage for that welcoming community that you want to build at your own institution. So there is your examples that are there, and the guidance is to reach out and solicit the help of others.
Thank you so much for that, Professor. I'm sure to all the listeners of this podcast, you can always look up on the notes and the references to the symposium that you're talking about and the kind of vibrant group that you're putting together along with your 8 professors. But what I could understand from this conversation with yours is that creating an academic maker spaces cannot be a half-hearted approach. It cannot be half-hearted. It's just not about taking a place and bringing some people together. It's a very, very organized way of doing things. There has to be programming, a robust programming, and consistent programming to keep students, teachers, and other parts of the community very, very engaged. And only then can fruitful results can come out of it, and any kind of organized pursuit requires funding. And that really is the oil that keeps it going. And that is a great segue to my next question, that what really are the successful business model do you think when it comes to academic makerspaces that have actually worked in attracting good amounts of funding? What do you think, Professor, are some of those business models that have proven successful in leading to academic makerspaces getting funding? And if I have to borrow a nugget of wisdom from the entrepreneurial world here, there's a word called bootstrapping. How long can you bootstrap your way to success in building up an academic makerspace?
So to take on your first question, to a certain extent, yes. But just like with bootstrapping in entrepreneurial spaces, it typically is the first step for something much more systematic, much more expansive, that it gets something created, a minimal viable product, if you will, and then you can solicit other resources. So you were very insightful to recognize that we're not just creating a thing. In essence, we're creating a business unit, an operational unit, a functional unit, whether it's at the university or within the municipal environment. So with that, in addition to the programming, the leadership, the finances to make things actually work. So there's actually, like any business, a couple of phases: the initial funding, the demonstration of technology, the solicitation of others to participate, and then to get into your normal operating system. So if I wanted to summarize this and using your bootstrapping concept, even if that bootstrapping is soliciting seed funds from your organization, from your alumni, from a government grant, but the first step is simply to fund it. Once you fund it, you can then go ahead and create it, and then add funding, and then expand it. So similar to the entrepreneurship work of getting the initial funding, creating a prototype, getting additional support, and then building and refining it. And so some of it within the United States, that has been the model for some of the programs that have, over a period of, say, 5 years, 10 years, increased their funding 50-fold, increased their footprint 50-fold, increased their users 50-fold over a period of 5 years, with that initial jumping in with the funding, creating, showing that there actually is success, and then using that as a reason for others, quite frankly, to invest within the makerspace. So as you're building this, you're really building this as a business, is that from a start, it needs a budget. It's going to have inflows of funds, sources of revenue, and then it's going to have the expenses. And so anticipating what those are and having the mechanisms to continue to receive funding as income and to be able to expand your services, maintain your services, moving forward, the expenses that you're going to incur. One last point, when it comes to expenses, the largest expense in all makerspaces actually is this professional staff, because you want someone waking up in the morning that is their fundamental purpose, and those staff costs are going to be your primary costs of operating the makerspace. So initially the cost comes from outfitting it, building the space itself, but then the operational cost, your largest cost is in your staff, and we've already spoken about how key that they actually are. So having the mechanisms to keep that funding there to ensure the integrity of the program is really, really key.
Thanks for that, Professor, and sort of highlighting that there have been some very successful examples like you highlighted, that in some cases the funding has been 50 times or they have been oversubscribed. So if I have to ask you that, how do you measure success when it comes to the building of an academic makerspace? Do we also see some kind of metrics when it comes to evaluating the success of a makerspace? What really are the parameters in which you assess the impact for an academic makerspace? And are these users, number of projects? Have you seen these metrics evolving for makerspaces to understand if they're driving meaningful outcomes? I mean, the question really is that how do you measure impact?
Again, very insightful on how do you measure the impact of your work? How do you quantify the impact of your work? And some of the developments within the academic makerspace community is not necessarily what is collected, but how it is collected. What tools are now available, what processing of the information on the use of a particular piece of equipment can now be automated. So like with everything, the data is important, and then it helps validate your impact on the community in one aspect. So if we take the concept of KPIs, key performance indicators, that is a term within the makerspace community that is accepted as demonstrating the value to the organization. As you said, it might be number of users, it might be the number of courses, it might be the number of projects, it might be the community that actually comes in. So the concept of, if it exists, is there a way of easily collecting that data and then using it to show your overall impact? So getting a baseline from the start and showing your impact over time is really, really key. In addition to the data are the anecdotes, the story of the student who had never soldered before that can come in and make a piece of, say, jewelry that lights up. The group of students that met within a makerspace and go off and form a company together. The experience of the researcher who had this idea that now comes to the makerspace and can put it into practice to track perhaps organisms within an environmental biology apparatus that they never had the chance of before. The climate change researcher who can now work with a group of students and develop a product to sample soil, heat up that soil, use electronics and determine the carbon content of the soil. So two things is the raw data, and the other is collecting these vignettes, these stories of impact that are really, really important. Some of the things that play into the makerspace itself, so you have to demonstrate your validity to others, but then also the use of data of improving your own systems. How do people hear about you? A survey, social media, from a friend, from a course instructor. What tools are commonly used within the makerspace so you can know where to guide your investments itself? What are students working on? Are they working on a class project, a personal project, some piece of art, a bit of research, so that you understand your community and that community itself can gauge these resources in programming and staffing, in equipment and financing to grow the program itself. Two other things on this use of data is going back to the concept that the makerspace is a learning environment. How do you quantify the learning? How do you measure the skills in design that are achieved by the users, the improvement of their outlook on engineering, their self-confidence, their skills in manufacturing, their attentiveness to safety? These are all key competencies that employers and researchers will look for, and it's a chance for our makerspace community to demonstrate their competencies for employment, for additional higher education. And the last component that I think is really important is seeing the impact of the makerspace on the selection of attending a specific university. So there's growing evidence that students are making decisions on attending universities because of this attribute. In the past, people have done things because of the libraries, perhaps because of their access to research, but it is now a decision point that comes into the students on selecting universities that have accessible and impactful makerspaces.
Thanks for that, Professor. Sort of really very well put that how makerspaces are proving to be such a key component in decision making on which university to go for, and what incredible examples that you gave on the kind of outcomes that have come from the makerspaces, the kind of project the students have worked on. I mean, so it's really a combination of art and science, that to allude to that. So art is where you measure the impact in terms of how many lives they've touched, and science is where it sort of comes down to the number of projects, the number of users and all that. You sort of build that, both are in combination, and perhaps attract the funding, the required funding to get the engine going. There's a certain bit of naivety when it comes to students, very endearing. I mean, all of us want to go back to school. That could really be the space where students might be not perhaps best equipped to understand the distinction between the rhetoric and what really is the reality. And students, when they are not necessarily able to transform their academic project into something that is market ready, what do you think what they can really do to get to the market validation early on? And what exactly do you think are the academic programs which can be done to better equip students to build for the market and avoid these pitfalls?
One of the examples that I use with students, since you had mentioned the role of art and science, is in creative writing. That when you would write, say, a poem or a short story or even an essay for a social studies class or even an engineering class, you don't sit down and create the final copy first. You go through this concept of an outline, you go through this concept of research, you go through this concept of first draft, second draft, and final draft. And so having students understand that that same developmental process for writing applies to the creation of products is really, really key. So that following that same template, that the challenge is to first to have a problem that you want to solve, have an idea, and come up with the first solution, i.e. your first prototype, and then quickly get to work on what is it physically, what is it electronically, what is it systematically of linking all the parts together. So that might even be done on paper. So then moving quickly from the paper, just like your initial outline, to the details, is the hardware software prototype. So taking that idea, creating something physical so that it works and you understand the working principles. And if you're going to now share this with others, chances are that a bunch of wires on a breadboard are not going to cut it. So how do you now take your prototype and move it into this version of a product that someone else can hold in their hand, that someone else can use your buttons to interface with, that someone else could use your physical device? So that takes that refinement aspect. So the whole concept of design, iterate, test, design, iterate, test is really fundamental for the students to realize and for them to comprehend that just like their award-winning essay that they may have written, there's many iterations before you get to that final product itself from that original concept. So what can educators do is actually welcome that and put it into the learning process so that your assignment isn't to build this product, but your assignment has various levels. Your assignment is what are some concepts. Your assignment is what is a foam mock-up, what is a breadboard mock-up of your design. Your next assignment is what is a functional unit. Your next assignment is what is an elegant functional unit that is easy to use. And you can sort of see how this is leading from this general idea to this refinement in both thought, the refinement in function, refinement in thinking of the students to create this commercial product. One of the things that we've actually done is we've built a system, a projects to products program, where we can guide students on this path, that they come in with either a personal project and a class activity following this series of design, iterate, and test. And this testing is not you in your dorm room, you within the community, it's the broader market of potential users. And so that test pool is expanding over time as your devices are actually expanding. At the far end of this process is the sunsetting, that either this product exists and can be turned into a company, it can be licensed, it can be the product itself sold to others to carry forth, or that the product gets sunset, i.e. the team moves on. It's a learning experience and they move on to their next experience. So that's the summary of how to go from this idea to refinement through this constant improvement and then market testing all along the way.
Professor, thanks for your insights. I have to draw your attention to something called over-engineering. Even that could be worrying, especially when it comes to students who just refuse to give up refining and innovating. You are just at it, but there has to be a time where you sit back and say, no, not anymore. This is the time to design for scale and manufacturing, and perhaps there's no such thing as the perfect prototypes. Sometimes in our pursuit of attaining the perfection, we are just at it, and that is where the educators and programs like this can be helpful and tell you that no, you have to stop here, and this is your time to sort of design and scale and manufacture.
So as you alluded to, the calendar is a great driving factor. And hand in hand with the calendar is actually the finances that are great driving factors. In your question, you alluded to the fact that it may be within a course, 16 weeks, 13 weeks, it may be over the life of a student, 4 years, but those time factors have to be a constant reminder in this initial activity that you're involved in, how much time is available for you to achieve the end result, whatever that end result might be. And then the finances that are associated with that. The tenacity of the students is, one of the very exciting things on the university campus, but also another exciting thing is the role of the advisors, of the faculty, of the mentors that may not just be within the faculty, but other entities of the university. Seeking out those guides from, as I mentioned before, the Department of the Environment, the athletic department, the art department is really, really key. And then adhering to their wisdom and guidance so that your view is not just yourself, but it's this wide perspective of others, and having the confidence in yourself to welcome the input of others is a really, really important aspect of things. Understanding that your end goal needs to be established early on in your process so that you have comfort of where you are trying to go to during this period of time. So if you have a course in 16 weeks and you say, we're going to build a commercial product, that may or may not be realistic. But if you have a course that says we're going to take an idea and make sure that we have a very solid idea coming out and a functional prototype that could develop into a product, actually is more conceivable. In this case, we're using that calendar, we're using that time restraint as actually our guide for the student experience itself. And so I think that that's an important, in summary, is recognizing what you're trying to do and how much time you have as the student to get to that endpoint. If it's 4 years and you're trying to develop a company, what can you do to have things in place for that company and not for the entirety of a corporation? What can you do to have things in place for that one product and not an entire product line? So that's really the challenge for the students and a great opportunity for the advisors at the university to help the students to get there.
Thanks for that, Professor. So it really boils down to having a very realistic idea of your ambition and aligning that with a finite timeline. That really is the key. How much of that is achievable and how much of that is just a dream that we want to pursue? And you use the word tenacity at the end of it. That is where the relentless pursuit of passion steps in. That is where you really want to achieve what all that you imagine. But perhaps success is not necessarily a straight line. You ought to understand that you have to learn to accept failure. There could be that outcome also. Sometimes all avenues are exhausted, and when that student gives up, it might take eventually a toll on their morale. I have to ask you this, Professor, that what could you tangibly advise to better help students to understand that with experimentation, failure is more of a stepping stone rather than a setback?
This really comes back to our first question of what is a makerspace, and in the guidance to the students on their intellectual development is in fact the reminder that during this wonderful period of life while you are a student, and I will add that that doesn't have to be reserved to when you're in university, but as a student, your primary focus is the learning environment itself. When it comes to this design, iterate, test, and at sometimes failure, what you're doing is you're investing in yourself, in that you're learning, and you're learning what needs to be done, your thought process, your ability to work with others, and then your ability to make a decision. Your decision making is part of the learning process itself. Hopefully along the way, that as you're developing this product, you're developing your own learning path, you're going to realize that for a commercial entity, the three most important things are in fact the team, the technology, and the market. And so as you have your experiences and something may not work, I think it's important for your personal development to realize, did this not work because of the team? Did this not work because of the technology? Did this not work because of the market conditions itself? And so during this learning process, that you realize that you can't do it all, you need the help of others, and that the key components that you can put your heart and soul into, the development of the technology itself, the development of the market and the sales, are avenues for you to learn from. So just like the library is a place to learn, the academic makerspace is a place to learn, this product development process in its entirety is a place for you to learn from and to experience this wonderful thing of both professional and personal growth. So that's what I find very, very exciting about the makerspace community is, in fact, it is a group of individuals, and we're all working to help each other learn, to help each other develop.
Thanks Thanks for that, Professor, and what an incredible conversation today. And I can't let you off the hook without asking you some questions on rapid fire. So I have to put you on the hot seat right now, and you have to give me like quick answers. If you were to tell me one overhyped technology, what would that be?
It's hard. And I know what you're trying to do, and you can see me being uncomfortable all of a sudden. I would say the overhyped technology for right now, everything that I do, I sort of do because there's a driving force, a driving interest in it, whether it's health monitoring, the development of AI. Behind me, we have robotics. So all of these things that I pay my attention to are the ones that I firmly, firmly believe in. As soon as we say goodbye, I'm going to remember, oh yeah, that thing was the fad, that thing was unimportant, that thing was disconnected. But I tend to get in things for decades and not for moments. So I'm trying to think of, what I might have looked at and passed on by over the time. So I'm gonna have to come back to that one, but it's a great question, and I appreciate it.
Okay, underhyped technology.
Underhyped technology is actually the availability of data and the use of data itself. A colleague in Singapore has corrected my view of robotics, is that they're really not electromechanical systems, but they are data, their compute, and then their actions itself. So where I say the importance of data, you saw this in the makerspace, you see this in the use of robotics with their use of sensors, you see this as the economic engine for growth itself of data, data, data.
Now the fun question, if you were to be stuck in an elevator with Sam Altman of OpenAI, and if you have 2 minutes with him, what would your conversation look like?
So I'd be very interested in obviously the future that he sees, but actually his role in the future that he sees. So it's easy to say that machines are going to think and they're going to be able to outprocess us. But here, Sam, you are the person that is in the position of guiding all of this. So where is your own development as a person involved in the growth of artificial intelligence?
Okay, Professor, if you have to think of one outcome which has come from the maker spaces over the years and really left a lasting impression on your mind, it could be one product, an experiment, one conversation with a student, what would that really be?
One of the key aspects is that you need the team around you to have this all happen. But as I've become more and more aware, the team starts with a spark plug. That's my term. Who is the spark plug? What ignites them? What gets them actually going? And so the observation and the ability to find these spark plugs, to create an environment where the spark plugs come to you and you just sort of facilitate and assist them, that's the most exciting thing about the work that I've been involved in finding those spark plugs that are self-igniting and then given additional resources can go ahead and just take off.
Thanks for that, Professor. I would really love to host you in India. This conversation was just so incredible. It almost took me back to my classroom days, this entire sort of analogy of iterating, testing, going back to the drawing room, and finally getting to the product. It really is like talking to a professor and copiously taking down the notes. So you have to tell me, when can I host you in India?
Let's work on that. I have had a number of invites to come to India, and I look forward to visiting at some point. The dilemma is all the work at hand for the day. So this afternoon I have a lecture on leadership, and we're building a new building. So the conflicts of the daily work, which is super exciting in its own right. So I look forward to visiting India. I will definitely give you a call and look forward to collaborating there on the concept of makerspaces and other type of learning environments. Sridhar, it's been a real pleasure, and I've enjoyed myself thoroughly. So thank you for the chance to chat.
Thank you so much, Professor, for your time and energy to this and joining us from the overseas for what was an incredible conversation. So as we close, do you feel a renewed sense of possibility and purpose? Do you feel like going out there and getting things done? You might have gotten the sense that an academic makerspaces, be it in India or the US, can be a sandbox for entrepreneurship and innovation that could lead to a lot of interesting outcomes when people persist in leveraging their creativity as opposed to living in autopilot. What would you do if you were certain in the belief that your ideas could become more impactful realities? Until we see you again, goodbye and good luck from Maker FM, and thank you, Professor, for joining me for this incredible conversation.